but it turns out to be that E is actually that Euler number, and e to the I theta represents a complex number, and it's virtually unit circle, even though E, the magnitude of E is 2.17, and theta goes from 0 to 2 pi as a period and continues like that, keeps going around counterclockwise, and still the sum is 0. E to the I theta plus 1 is 0 wholes, no matter how many radians, how many pi radians you have. 5 million pi radians, and you're still that plus 1 equals 0. Now pi there is not 22 over 7 or 3.14. Pi is an angle in radians. 360 degrees equal to pi radians. In that area is an angle, not a length, not a number. So similar argument was for E. You see 2 pi radians is equal to 360 degrees. Two pi radians means you go full circle, right? But when you calculate the circumference of a circle, C is equal to 2 pi r, because 2 pi is a full circle. Now 60 pi and 30 pi e to the I theta would probably give you the same number. But to do that on a circle to calculate the circumference, you'll go somewhere between here and the utility pole. See? So when they say it's a beautiful number, it has pi, which is a constant, right? But pi in that case is a constant, but not the same constant that we use in this case. Whatever you have, like 60 pi and 30 pi will bring you to the same position on the plate, on the circle. But if you have a circle of 60 centimeters in radius and 130 centimeter in radius, you'll have a different circumference. So something to that effect, I was thinking about the E. But for the unit circle, it turns out that that is not the case. That it is exactly e to the I theta plus 1 is equal to 0. And they got E from percentage calculation. And percentage calculations use parts of 1. Parts of 1. And here we are using a circle of unit radius 1. So that's why it comes in, right? I don't know that, but it makes sense, right? In America, when you calculate 80% of something, you say 0.8 times that. You always make it something between a decimal between 0 and 1. Now, the circle, right, I pi, I theta, when it goes around, the components of the x and y parts never exceed 1. Just like the interest rate calculation, that factor that we use never exceeds 1. That may be the reason that Euler's number comes in there. It has nothing to do with percentage but the number 1, right? I'm thinking intuitively. And now the pi there is not the same pi. It looks like the same pi, but it means something different. And it's used in a different way. You don't use pi as an angle in area and circumference calculation. You use it as a factor. In e to the I theta, you use it as an angle.